the last class, we had an introduction to decimals. In this class, we will study the classification of decimals based on the number of digits in its decimal place. Suppose you have borrowed 25 rupees from me. And when it is time to return, I tell you, why don't you give me this much? Then what will you say? No way, these two are completely different numbers. Then what about this? These two numbers are one and the same, right? Why is that? Adding zeros before a whole number makes no difference to the value of that number. Similarly, if you take a decimal number, then adding zeros after the decimal part makes no difference to its value. These two numbers are one and the same, or in other words, adding zeros before the whole number part or after the decimal part makes no difference to the value of a number. And why is this important? It is based on this that we are going to classify the decimal into two types, like decimals and unlike decimals. But it is not just for mathematical uses. Even in your daily life it is important, because you need to know this when it comes to converting units of currency. Let me show you an example. Consider this amount. It is rupees 2.5. Can you tell me how many rupees and how many paisa are in this? A very common mistake that we see is this: 2 rupees 5 paisa, which is the wrong answer. The correct answer is 2 rupees 50 paisa. Before we proceed, let me tell you one thing. Here I am taking the Indian currency. Here I am taking rupees and paisa. But you can take any currency in the world. You can take dollars and cents. You can take pounds and pence, dirhams and fils. You can take any currency. The basic breakdown will be same. You will have a larger unit and you will have a smaller unit of currency. And 100 parts of the smaller unit will be equal to the bigger unit. We know that 1 rupee is equal to 100 paisa, and you will see the same breakdown in whichever you take. Dollars and cents you take, there will be a bigger unit, a smaller unit, and the breakdown will be pretty much the same. Now, how does this conversion take place? Suppose this is the rupees column and this is the paisa column. How many places can the paisa column have? It can have maximum only 2 places. Why is that? It starts with 1 paisa, it ends with 99 paisa. After 99, once it becomes 100 paisa, it becomes 1 rupees. So, from here it jumps back here and makes this 3 rupees. So once you have 100 paisa here, it becomes 3 rupees. It goes to the rupees side. So this is the maximum you can have here. 2 digits is the maximum you can have in the paisa column. So what does this actually mean? There is nothing here. That means there is actually a 0. You have just not bothered to write it. So 2.5 is actually 2 rupees 50 paisa. Then the question arises, how do you write 5 paisa then? There. This is how it is written. 2 rupees 5 paisa is this. 2 rupees 50 paisa is this. Now, why is this property important? This leads us to classify the decimals into 2 types, like decimals and unlike decimals. Let us see. So here you see 2 groups of decimals. What do you notice about the first group? All the decimals have the same number of digits in its decimal place. 3 digits, 3 digits, 3 digits. So such decimals are called like decimals. This group, 2 or more decimals are said to be like decimals if they have the same number of digits in their decimal place. Now, what do you notice about the second group? In the second group, They do not have the same number of digits. This one has 5 digits. This one has just 1 digit in its decimal place. This has 3 digits in its decimal place. So these are known as unlike decimals. But then if you take any two unlike decimals, what do you notice? What is the property that you just now learnt? Adding zeros after the decimal part makes no difference. So you can take any two unlike decimals and make them into like. How? By adding that many zeros. See, you have taken an unlike decimal, made it into a like decimal. Why? Why did we do that? Because that is the only way we can add and subtract. To add and subtract two decimals, we need two like decimals. Let us see how to add and then subtract these two decimals. Now you can see these are unlike decimals. So first make them into like decimals. Then place them in such a way that the decimal points coincide with one another, in such a way that the decimal points come one below the other. And even before you start adding, can you guess what the whole number part will be? You don't even have to add for that. Why is that? Look at the first number. It lies between 43 and 44. Look at the second number. It lies between 2 and 3. And so the answer should lie between 45 and 47. So even before you add, you can guess that the whole number part here is going to be 45, 46, 47. One of these numbers. Now, have you heard the story of that teacher who asked a student what is 10 plus 10? And the student said 28. The teacher was very happy. She said, well done. And somebody was passing by that way and that person asked, he just said 10 plus 10 is 28. What are you so happy about? And the teacher said, yesterday he said it was 58. Today he is closer to the answer. So we all know that in maths there is no such thing as closer to answer. Either you are right or you are wrong. But there is a reason why I am mentioning this, because I see this question often asked in the multiple choice questions, what we call the MCQs, right? I often see this type of questions. In MCQs, you have only 1 mark, so there is no use doing the whole thing. So such a question is asked and the options are given 0 point something, 46 point something and 102 point something. So there is no use wasting time. You can just look at it and see that the answer has to be 46 point something. You don't have to waste time doing the whole thing. So that's why I just wanted to mention this. So how do we add? 0 plus 8, 8, 7, here 1, this is 11. Remember, the carryover values can jump to the left and to the right of the decimal point. No problem with that. So here it is 11. The carryover jumps over the decimal point here. And this is 6 and there. This is your answer. Now, how do we subtract? Similar way. The subtraction also the similar way. You don't even have to do this, but you can get what the whole number part will be. The whole number part will be what? It will be 40, 41, 42. It will be in that range. Because if you subtract 43 and 2, you will get 41. So go forward one number, backward one number. It will be between 40 and 42. Your answer should be that. So now, unlike decimals, make them into like decimals. You cannot subtract 8 from 0 or 7 from 0. So borrow from here. This becomes 9. This becomes 10. Now you cannot subtract 9 from 1. So you borrow from here. Remember what I told you? The carryover values can jump over the decimal point. No problem with that. Left or right it can jump. So this becomes 11. And remember, your decimal points should always coincide. Remember that the decimal points should coincide. So this is how you do your subtraction and addition. And next we go on to the multiplication of decimals. Now let us move on to the multiplication of decimals. An easy way is to get rid of the decimal points and then multiply them as whole numbers. So let us see how that looks. Now, if we get rid of the decimal points, how will this number look like? There, we have got rid of the decimal points. Then what is this number? 035, 035, it is just 35. What is this 204? It is 204. So, remove the decimal points and then multiply them as whole numbers. When you multiply this as whole numbers, what is the answer you get? 35 into 200 plus 4. I will use the distributive law. I'll get the answer easily. 35 into 2 would be this. 35 into 2 is 70. Add 2 zeros. 35 into 4 is this. So this is your answer. Now, you will see that all the four questions that I have written down here are actually some form of 35 and 204. Look at all these numbers. See them without the decimal point here. Without the decimal point, you will see that all these numbers are some form of 35 and 204. Similarly, all the answers will then be some form of this. What form? How are the forms going to be different? Let us see. Now look at these two numbers. How many digits in the decimal place here? 5 digits in the decimal place. Here 3 digits in the decimal place. Together 5 plus 3, 8 digits we need here in the decimal place. But then we have only 4 digits. For the remaining 4 digits, add 0. There. This is the answer. Now, why are we adding zeros here? Why not here? We just learned that property, right? Adding zeros after the decimal place is of no use. We need 8 digits in the decimal place. So this is our answer. Now, what do you see here? How many digits in the decimal place? Here, no digits in the decimal place. This is just 35.0, right? So there are no digits in the decimal place. Here, 1 digit. So the answer remains the same. We just need 1 digit here, or in other words, the answer is 714. What about this place? The whole number that we need, that remains the same. Just its form changes. So how many digits in the decimal place? 2. 1 digit here. Together we need 3 digits in the decimal place of the answer. So start counting from here. Everything you start counting from here. 1, 2, 3 here. There. Or in other words, this is the answer. Because adding that 0 there makes no difference. Now what about the last one? Again, here 3 digits in the decimal place, 3 digits in the decimal place, together 6 digits. There must be 6 digits in the answer, but we have only 4 digits. We need 2 more digits. There. This is your answer. You can remove the last 3 over here. So this is the answer. So how do we multiply decimals? The first step, make decimals into whole numbers. How do we convert them into whole numbers? We just remove their decimal point and then they will become a whole number. And what is the second step? The second step, you multiply all the given numbers. And what is the third step? You put together, you take the sum of all the decimal places of the numbers you are multiplying. Here we are multiplying only 2 numbers, but as many decimals you are multiplying, just find the sum of all their decimal places. That is the third step. Then fourth, you have to place the decimal point in the answer. That is all. Finished. You have got your answer. Now there is one more step which, as I said, is optional. It is totally optional. You can do that step or you can completely skip it. It will not make any difference. What is that last step? Getting rid of all the unwanted zeros at the end of your answer, after the last non-zero digit of your answer. What is the last non-zero digit? There are zeros here, but what is the last non-zero digit in the decimal place? It is 4. Whatever comes after 4, you can get rid of it. Even if you leave it there, no problem, but better to skip it. Just try finding this answer in your calculator. Even in your calculator, you will see that after 4 you will not see any zeros. After the last non-zero digit of your decimal place, you will not see any zeros. In the calculator, you can double check it because it is understood. See here, totally 1 decimal place here, 2 here. So the answer should have 3, but it has only 2. So what is it? It is understood. It is understood that there was a 0. You just did not bother to put it there. So that is all. We will just see one more example. Now let us just try multiplying 3 numbers. The procedure is exactly the same. What is the first step? Get rid of the decimal points and make these decimals into whole numbers. Here there is an unwanted 0 there, but anyways I have dropped it. You don't have to worry about it. These are the 3 numbers that you have. So what is the first step? Make them into whole numbers. There. We have got rid of the decimal points. So this number is now 125, this number is now 35, and this number is now 4. Multiplied, group these two together. 125 into 4 will give you 500. First group these two together and then multiply. Your answer will be 17500. This will be the answer, but this is not the answer we need. We need the answer for these decimals. So what is that answer? 3 decimal places here, plus 1, plus 1. So totally we have 5 decimal places. So that should be counting from here. 1, 2, 3, 4, 5. Or in other words, your answer is this. Now we come to the last and the final topic of this lesson. Now let us see how to divide and multiply decimals by powers of 10. What do we mean by powers of 10? Numbers which are this: 10 raised to 1, 10 raised to 2 which is 100, 10 raised to 3 which is 1000, and so on. 10,000, 100,000, etc. It just goes on, right? So first let us see how it works with whole numbers. We already know how to multiply whole numbers, right? Let us take the same example. So what do we do here? We just add a 0. And what do we do here? We remove a 0. So when you multiply, you are getting a bigger number. You started with a 20, you have got a 200. You started with 20, but when you are dividing, your answer has become smaller. It has become 2. So more or less it is the same thing with the decimals also. Let us see how it works. When you multiply with 100, all you have to do is move the decimal point 2 places ahead, 2 places forward. Why 2 places forward? Because 100 has 2 zeros. If you are multiplying it with 10, just move the decimal point 1 place forward. If you are multiplying it with 1000, 3 places forward. Depending on the number of zeros here, move the decimal point that much forward. Or in other words, your decimal point is here. So your answer is this. So you see what has happened? You started with 63. But you have ended with 6,375. You have got a bigger number. And how do you divide? The same procedure, but make the decimal point come backward. What happens then? Your number becomes smaller. Here, 2 places backward. Now this is your number. This is the answer that you want. So you see what happened when you are dividing with 100. You have started with 63, but you have ended with what? You have ended with 0.6375. So you started with a number between 63 and 64. You ended with a number between 0 and 1. So you see what is happening here? Is this magic? Are we doing some trick here? No, it is exactly the same multiplication technique that you just now learned. How did you multiply those numbers? First, get rid of the decimal point, and what you have now is two whole numbers. Multiply it, then count the decimal places in the question. There are just two. Here it is already a whole number. Then there, see, it is just the usual method, but we are skipping all these steps and just moving the decimal point forward. In case of division, we are just moving it backward. We will see one more example. So what happens here? You see the decimal point is here. You have to move it forward by 2 places, but you have only one digit here. What do you do then? Just add a 0. There. You started with a 3 point something, but you have ended up with 370, right? Because you are multiplying it, your answer will increase. What about the next one? You have to go back by 2 places, but there is only one place. Then what will you do? Z. Make sure the zeros that you add come in between the decimal point and the answer that you have. So this is what happens when you multiply or divide by the powers of 10. Every number has a basic structure. It has a basic DNA to it. So that does not change. This 37 does not change. What you do is you just make it bigger or smaller by adjusting this decimal point. Moving it forward makes the number bigger. Moving the decimal point backwards, that happens when you divide. When you move it backward, it becomes smaller. So that is all for today. Till I meet you next time, you take care. Assalamu alaikum.